Good morning, dear students. Last class we studied about the mode of energy transfer, that is heat and work. And work done for contraction is generally positive, and work of expansion is generally negative. And work done by the system is negative, and work done on the system is positive. Similarly, heat absorbed by a system is generally given the positive sign, and heat released from the system is generally given the negative sign. And what is the work done for irreversible process? And what is the work done for reversible isothermal process? We have discussed. Now let us solve some problems regarding this concept, and later we will discuss some other portions. So first, there are three questions. Let us start from question number 3. Calculate the amount of work done when 3 moles of an ideal gas at 27 degrees Celsius undergo reversible isothermal expansion from 20 liter to 40 liter. So work done for expansion, this is only given the negative sign for expansion, and for contraction there is the positive sign. This is the difference, but magnitude generally same. So W reversible minus for reverse, this is given reversible and isothermal. So for that the formula given to you minus 2.303 nRT log V2 by V1. So prove the formula. W reversible minus 2.303 n given the first formula nRT log to the base 10 V2 by V1. Okay, so minus 2.303 n value, this is given 3 mole, R value at the energy term 8.314 joule Kelvin inverse, mole inverse, and temperature that is given 27 degrees Celsius, 27 plus 273, that is 300 Kelvin into 300 Kelvin into log V2, 20, 40, final is 40, 40 by 20. So in this case, this value minus 2.303 into 3, 8.314 into 300 into, it is given log 40 by 20, log 40 by 20, log 2. So log 2, and log 2 has value, 0.301. So substitute this value and we will get the answer minus 5186.96 joule. Okay, so minus 5186.96 joule. Just multiply and put the value of log 2 0.301 and you will get the answer 0.5186, 0.96 joule. Okay, so this is the how to solve this type of problem. Next come to question number 2. So calculate the amount of work done in joule when the gas expands from 10 liter to 40 liter. Again, our external pressure of 10 atmosphere. So the external pressure is 10 atmosphere and volume gas expands from 10 liter to 40 liter. So sudden change, and this is the external pressure is 10 atm, that the constant pressure is there 10 atm. This is not changeable. Okay, for reversible the P is not constant. For irreversible this P is constant. And the value is given, the pressure has value given. From that you can know this equation is for irreversible process. Okay, so in this figure also expansion is given. W is equal to minus P external into del V. So P is given 10 atmosphere and del V is given, that is from 10 liter to 40 liters, final volume minus initial volume 10 liter, that is 300 minus minus 300 liter atmosphere. But the question is asked you in joules, and you know 1 liter atmosphere equal to 101.3 joule. Okay, so it is equal to 300 into 101.3 joule, because 1 liter atmosphere is equal to 101.3 joule. So substitute this value and multiply by 300, and you will get 30390 joule. 90 joule, that is 3.039 into 10 to the power 4 joule. Okay. So in this way you can solve. Next, question number 1 is also the same way. Note down this. So question number 1, a gas expands against a constant pressure of 1 atmosphere. Calculate the work done in joule and in calories. So here the question is gas expands against a constant pressure. Pressure is given, but how much volume change is not given. So question is slightly wrong. So just I want to correct this question. A gas expands by 0.5 liter. A gas expands by 0.5 liter against a constant pressure of 1 atmosphere. Calculate the work done in volume and in joule and calories. So your del V is already given 0.5 liter, and it is given, that is expansion is given, so W is equal to minus P del V. So P is 1 atmosphere, 0.5 liter, 0.5 liter atmosphere. Don't forget to give negative sign. Negative sign. In the previous questions, if I have not given negative sign, to just previous answer, if I have not given a negative sign, we just put the negative sign, because work of expansion is negative. So minus 1 atmosphere, 0.5 liter, minus 0.5 liter and atmosphere. But given question, find out what the work in joule and as well as in calorie. So 0 minus 0.5 into 101.3. So in this same 101. So just multiply by this joule. Okay. So this answer is that is 50 minus 50.65 joule. Similarly, another is given, that is in calorie. So 0.5, it is equal to 0.5 and 24.206 calorie. 1 liter atmosphere, 24.206 calorie. In this way, substitute this value minus 0.5 into 24.206 calorie. So multiply this and answer will be minus 12.103 calorie. So we will minus 12. So in calorie the value is this much, and in joule this value is this much. But don't forget to give the negative side if it is given the expansion, and if it is given contraction, then give the positive side. Now come to next term, that is internal energy. So what is internal energy? The total energy stored in a system is known as its internal energy. So this energy, what is the energy stored in a system? That is due to its atomic arrangement or due to the bonding formation. If some bond is formed, then what the electrons are present, due to some electrons have some energy. What are the other particles present in atom? For that also it has some energy. What are the particles present in a molecule? So nuclear energy, electrical energy, electronics energy, vibrational energy. So due to which if the molecule is formed against it bond, some vibration takes place and the molecule rotates, rotational energy. So all sorts of energy what is generally stored in a system, that is known as its own energy or the internal energy. And this internal energy is represented either by a letter U or by a letter E. Okay. So the absolute value of internal energy cannot be determined. So how much energy stored in here we cannot determine. For how much energy stored in a system that cannot be determined. But if a system undergoes some change from one state to another, from one condition to another, the change in internal energy can be determined. So the change in energy either in the form of some loss of heat, either in the form of some temperature or some volume. In some cases, in the different form, what is the change in internal energy that can be determined. The change in internal energy can be determined, but the absolute value of internal energy cannot be determined. And as it is the energy term, its unit is joule or calorie, like this. If we take for mole, then per mole is also joule per mole or calorie per mole. In this way, you can also determine. And this internal energy is a state function. It does not depend upon the path, how this process carried out. Internal energy does not depend on it. It is depends upon the initial condition and the final condition or the change in internal energy. Okay, so it is the exact differential. So these are some characteristics of internal energy. So what is the total energy stored in a system, that is known as internal energy. And the change in internal energy at constant temperature or in isothermal process is equal to 0. If there is no change in heat energy or no change in temperature, then the internal energy change del U, that is equal to 0. Okay, so write down some points on internal energy. So note down these points. Internal energy system having every system having some quantities of matter is associated with a definite amount of energy, that is called internal energy. It is the sum total of all types of energy, that is the E equal to E vibrational, E rotational, E electronic, different types of energy. What are the system were stored, that is known as your internal energy. So we can write E in E or U. So U is equal to E vibrational plus E rotational plus E electronic plus so different form of energy. It is impossible to calculate, as it is the sum of all types of energy. It is impossible to calculate the absolute value of internal energy, but the change in internal energy can be determined, because if a system changes from one state to another, or the change in energy that can be determined. What are the characteristics of internal energy? So it is an extensive property, as it depends on the amount of the substance. If the amount is more, then the internal energy is more. It is a state function, as it depends on the initial and the final state. There is no change in internal energy for a cyclic process. That means del U is equal to 0 for cyclic process. Internal energy depends upon the quantity of the substance, temperature, pressure, volume and chemical nature, etc. So for an exothermic reaction, del U is negative, that is the energy of reactant is greater than the energy of product, so that so when UP minus UR is there, that gives a negative value. Okay, or as the energy of the reactant is more, it gives product and some amount of energy. So in this way, for exothermic reaction, del U is negative, and for an endothermic reaction, where it is absorbed, del U is positive. Your energy of reactant is less than energy of product, or internal energy of product is more than the internal energy of reactant. The unit of internal energy is joule or calorie, etc. So note down these points. Next come to first law of thermodynamics. So what is first law of thermodynamics? So there are different laws for this thermodynamics. This first law of thermodynamics is also called law of conservation of energy. So according to this, energy can neither be created nor be destroyed, but it can change from one form to another. So when an equivalent amount of some energy disappears, then when an amount of energy disappears, then equivalent amount of another form of energy that may appear. Okay, so it is impossible to construct a perpetual motion machine which can do work without consuming any energy. So all the things are the same, that is energy of the universe is conserved. The total energy of the universe remains constant. Either the energy transfer takes place from system to surrounding or from surrounding to system, the total energy of the universe remains constant or conserved. So these are known as first law of thermodynamics. Mathematically, this first law of thermodynamics represented as del U is equal to Q plus W. Where del U, that is the change in internal energy, change in internal energy, and Q, this is the amount of heat absorbed. Amount of heat generally represented by Q, amount of heat absorbed by the system. So heat absorbed means it is given positive sign, and as W is also given positive sign, there is the work done on the system, and W is your work done on the system. Okay, so mathematically, so this Q and W that may be positive and negative depending upon what are the type of work done, or whether heat is absorbed or whether heat is evolved or released from the system. In this way, they have different value, but in general form, we can write del U is equal to Q plus W. Okay, suppose a system generally generally has internal energy U1 and it absorbs some amount Q amount of heat, and if the W amount of work is done. So initially its internal energy is U1, and after absorbing some energy and after if some work is done on the system, then its energy changes. Let its final internal energy is U2. Then what is your U2? Then U2 is equal to U1 is the first, it absorbs Q amount of heat and W amount of work is done on the system. Then U2 is equal to U1 plus Q plus W. Then what is the difference between U2 minus U1? That is equal to U1 plus Q plus W minus U1. So U1 will cancel, that is equal to Q plus W. And U2 minus U1, that is also represented as del U. So del U is equal to Q plus W. So in this way, this law is derived. That is known as first law of thermodynamics. And if heat is evolved from the system, released from the system, then you can write W is equal to minus Q plus W. And if heat is absorbed by the system, and if the system does W amount of work, the system does W amount of work, and work is done by the system, then this equation can be represented as del U is equal to Q minus W. Q minus W. And if work done is equal to 0, suppose this is your free expansion of gas or expansion of gas. So in some cases, if the del V is equal to 0, no change in volume, if the pressure is equal to 0, then what happens? Del U is equal to Q. So what is the heat absorbed? That only changes the internal energy. So del U is known as your change in internal energy. Okay. So what is the amount of heat that is only responsible for the change in internal energy? So the internal energy change depends on what is the heat absorbed or produced by the system as well as it depends on what is the work done on the system or by the system. So this is known as the first law of thermodynamics. So note down these points. So note down these points. First law of thermodynamics is also called law of conservation of energy. It can be expressed in different statements such as energy can neither be created nor destroyed, although it may change from one form to another. The sum total of energy of the universe, the sum total of energy of universe remains constant or conserved. That is the energy of system plus surrounding. That is always a constant. Whenever a certain quantity of energy in one form disappears, an equivalent amount of energy in another form reappears. It is impossible to construct a machine, perpetual motion machine. That means a machine which can perform work without consuming any energy. That means what is the change in energy? That is due to some heat absorbed and that is due to some work done. So in this way, this can be represented as del U is equal to Q plus W, where del U is change in internal energy, Q the amount of heat absorbed by the system, W amount of work done on the system. So for the mathematical expression, let a system having internal energy U1 absorbs Q amount of heat and W amount of work is done on the system. So then the final internal energy of the system, that is U2, so initially U1 and absorbs Q and W amount of work is done on it, work done on the system is positive. So U1 equal to U2 is equal to E1 plus Q plus W, or U2 minus E1 is equal to Q plus W, or U2 minus E1 is del U is equal to Q plus W. Or if heat is absorbed by the system, then positive. Heat is released from the system, it gives the negative sign. And similarly, if work is done on the system, it's positive. If work is done by the system, it may be negative. So in this way, in some cases, the Q may be negative and this W is also negative. So if we substitute this value, then we can write this change in internal energy del U is equal to plus minus Q and plus minus W. Let us solve one problem like this. A system absorbs 500 joule of heat. That means Q is equal to 500 joule and does 50 joule of work on it. So W here is negative, that is minus 50 joule and does. So work is on its surrounding. That means work is done by the system. So as work is done, system does some work. That means work is done by the system. So W is negative. That means 50 joule. Then what is the change in internal energy? Del U is equal to Q plus W. So that is 500 minus 50. 500 minus 50 joule. That is 450 joule. So in this way, you can solve what is the type of problem. Okay. Next, come to another energy factor, that is called enthalpy. And enthalpy is actually the most important factor. Okay, enthalpy, it is represented by letter H. Already you have listened this name in bond, ionization enthalpy, bond enthalpy. So enthalpy, this is one energy factor. Okay, so this is one energy term. So what is enthalpy? So generally, what is the internal energy? The internal energy or the change in internal energy is generally measured at constant temperature and constant volume. So what is the change in internal energy? Generally that is measured at constant temperature and constant volume. So the energy of a system at constant temperature is known as energy of a system at constant temperature. So if the temperature is kept constant, but the energy stored in that is known as its internal energy. But whenever any chemical reaction takes place in the surrounding, generally pressure of that remains constant. So due to some chemical reaction, in some cases energy is released, in some cases energy is absorbed. Such energy is released, energy is absorbed. At that time, the variation of temperature may take place. And similarly, by addition of all these substances in chemical reactions in a different environment, if some different moles are added, or if some different liquids are added or solutions are added, then also change in volume takes place. In some cases, change in volume takes place. So by adding some number of moles, the volume changes. So in this way, but the pressure of the system remains constant. So the energy of a system at constant pressure is termed as enthalpy. So instead of taking internal energy, the total energy stored in a system is known as internal energy. But generally maximum reactions takes place at constant pressure. In this way, the energy of a system measured at constant pressure is known as enthalpy. So enthalpy is related with internal energy. So this enthalpy is the sum of the internal energy and some external factor like pressure, volume, work. So mathematically it is represented by a letter H, and H is equal to U plus P into V. So H is equal to U plus P into V. Okay. So the change in internal energy generally measured at constant pressure. Suppose a system has enthalpy H1. So its internal energy U1, pressure P1 and volume 1. So this enthalpy is the sum of internal energy and pressure volume work. This is your enthalpy. So H1 is equal to P1 plus PV1. Similarly, another H2 that is equal to U2 plus PV2, P2, V2. Then what is the change in enthalpy? Del H, that is H2 minus H1, that is U2 plus PV2 minus U1 plus PV1, P1, V1. But as pressure is constant, look here, as P is constant, so in this way, P1 is equal to P2. So as P is constant, P1 is equal to P2. So here we can write U2 plus PV2 minus U1 plus PV1. Or you can write U2 minus U1 plus P taking common, that is V2 minus V1. So U2 minus V1 and P taking common, V2 minus V1. Or you can write del U plus P del V. So del H is equal to del U plus P del V. That is, the enthalpy change is equal to change in internal energy and pressure in change in volume. Okay. So note down somehow. Another thing here I want to say, this enthalpy is also a state function. This is also an exact differential, and this is also an extensive property because it depends on the amount of the substance. This is the extensive property, and the unit of enthalpy is generally joule, calorie, or like this. The energy of the units of energy. Okay. So instead of energy, the better to write, instead of it is better to write the term is enthalpy. Okay. So note down some points about enthalpy. So note down the points on enthalpy. The heat content of a system at constant pressure is known as enthalpy. But the heat change takes place at constant pressure in any system, that is known as enthalpy. It is denoted by H. So if the sum of it is also expressed as the sum of internal energy and pressure volume work. Mathematically it is represented as H is equal to U plus P into V. So it is an extensive property, it is a state function, exact value of enthalpy cannot be determined, but the change in enthalpy can be determined, and it will be the same as that of the entropy, as that of the internal energy, it is joule or calorie, etc. Suppose a system having enthalpy H1 changes to enthalpy H2, that is one state to another state, that is a state function. Okay, so as from the mathematical relation, we know H is equal to U plus PV. In this H1 is equal to U1 plus P1 V1, where U1 is the internal energy, P1 is the pressure, and V1 is the volume of when the enthalpy is H1. Similarly, when the enthalpy is H2, U2 is the internal energy, P1 is the pressure, P2 is the pressure, and V2 is the volume. So then what is the change in enthalpy? That is final minus initial, that is H2 minus H1, that is U2 plus P2 V2 minus U1 plus P1 V1. So as the pressure is constant, so P2 is equal to P1, let it be P. So substitute the value of P, or you can write U2 minus E1 P2 V2, or del H is equal to del U, U2 minus E1 del U plus PV2 minus PV1. Taking the P common, V2 minus V1, that is del V. So in this way, del H is equal to del U plus P del V. Now next find out what the relationship between this del H and del U. What is the relationship between delta H and delta U? This is the enthalpy change and this is the internal energy change. So from this last equation, here we find delta H is equal to delta U plus P delta V. This is equation 1. From ideal gas equation, we know PV is equal to nRT. So P is the pressure, V is the volume, and number of moles, R is the universal gas constant, and T is temperature. So the internal energy change that is taken at constant temperature, and P, that is the enthalpy change, P is constant and R is constant. So as P is constant, R is constant, and T is constant. We have taken R is universal gas constant, we have taken P and T constant. This is for internal energy and this is for enthalpy. We have taken constant. Then this B is directly related with what? This B is related directly with number of moles. So we can write that is P, we know PV. So this implies that P delta V is equal to del N R T. But look, number of moles. So this volume change, by changing the system, this volume change generally takes place in which case? If you apply pressure, equilibrium temperature in solid and in liquid, the change in volume is generally not considered, because by applying pressure in solid and the liquid has no change in volume, very small change. So actually this volume changes takes place maximum in case of gaseous state. So in this way, the change in volume as more maximum is exhibited in gaseous form. In this way, this del N is represented for gases. So, and you know this ideal gas equation, I have already taken this ideal gas equation. Why I have taken ideal gas equation? Because at applying pressure in solid and gases, they do not change their volume. So in this way, for gases they change its volume. So in this way you can write P del V is equal to del mg/T. Simply del mg/T. So this G only stands for gaseous state. Okay, that indicates the gaseous form or that. So what is this del M? This del M, that is the difference in number of moles of product and number of moles of reactant. That is number of moles of product minus number of moles of reactants, products and reactants. This is the relation, that is del H. Substituting the value of P del V in equation 1, substituting the value of P del V, substituting the value of P del V in equation 1, we get del H or delta H is equal to del U plus del Mg RT. So del H is equal to del U plus del Mg RT. This is equation 2. Now let us solve one problem regarding this equation. Okay. Look here, this question. So when liquid benzene is oxidized at constant pressure and at 300 Kelvin, the change in enthalpy is minus 3728 kilojoule. What is the change in internal energy at the same temperature? So for that, first we have to write a balanced equation for that. So when 1 mole of benzene is oxidized, for that we have to write down this formula. Write the equation. The equation is C6H6 benzene liquid plus 15 by 2 O2. This is gas. So what is the state? You have to write down first. So that to solve this problem, first we have to write down what are the states of there. What are the phase? This is existing liquid phase. This existing gaseous phase. This gives rise to again 6 CO2 gas plus 3 H2O liquid. Okay. Then what is this? Del Mg, number of moles of product, number of moles of reactant. Now the all. Only have to consider the gaseous moles. Number of gaseous moles of product minus number of gaseous moles of the reactants. So here given 16, 6 minus 15 by 2. Gaseous moles, not 6 plus 3, the total moles 9. This is not only 6, okay? And here not number of moles of gaseous moles, here 15 by 2 and here 6. So 6 minus 15 by 2, that is 12 minus 15 by 2, that is minus 3 by 2. Okay? Now for the formula, del H is equal to del U plus del Mg RT. So del H value given minus 3728 kilojoule is equal to del U plus, not plus minus 3 by 2. So in this way here minus 3 by 2 and R value you know 8.314 joule Kelvin inverse mole inverse, but this is given in kilojoule. In this way 8.314 into 10 to the power minus 3 kilojoule. So you have taken in kilojoule form 8.314 10 to the power minus 3 kilojoule Kelvin inverse mole inverse, and the temperature is given, that is 300 Kelvin. So find out this value, and from here you can find out del U is equal to minus 3728. So del U is minus 3728 and this total term comes here. So 3 into 8.314 10 to the power minus 3 into 300 divided by 2. So this value you can find out, that is equal to minus 3724.2587 kilojoule mole inverse. So del U is equal to this much. So in this way, so just multiply this and divide by 2, you can get the answer, and just value 3.7 something you can get. So just subtract it, you will find this answer. So del U value is equal to like this. Okay. here I want to say another relation also. Okay, so first solve this problem. So del H is equal to del U plus del Ng RT. Okay, so if this del Ng value is negative, if the del Ng value negative, example in the case N2 gas, 3H2 gas give rise to 2NH3 gas. So here del Ng 2 minus 4 is minus 2. Okay, so when del Ng value is negative, del H is equal to del U minus 2 into R into T. So this is positive, and this term is positive. So in this set del Ng is negative, then del U minus something give rise to del H. Del U minus something give rise to del H. So in this, if del Ng is negative, then generally del H is less than del U. Okay, del H less than del U. Similarly, if del Ng, if del Ng is equal to 0, example H2 gas, I2 gas give rise to 2HI gas. That is possible. So here del Ng is equal to 0. So del U plus 0 into RT. So in this case what happens? So if del H is in this case del H is equal to del U. Similarly, if del Ng is positive, example suppose given PCl5 give rise to PCl3 plus Cl2, all are in gaseous form, then here del Ng is equal to 1, that is 2 minus 1 is equal to 1. So del H is equal to del U plus 1 into RT, something is added. So in this way, del H is greater than del U. Okay. So if del H is negative, then del H less than del U. If del H equal to 0, then del H is equal to del U. And if del H is positive, then del H greater than del U. So remember this. Next class we will discuss some other questions.